All right, for people joining this live stream, we are talking about incremental language development as we head into version 12.2 of Wolfram language. So we are trying to finish off a bunch of things here, and that means we're writing a bunch of documentation. And let's take a look at axiomatic theory. So what did we conclude last time? We concluded that we're on a glyph hunt. Is that right? That we're going to find some new glyphs to put in here. Is that correct?
You mean for the formal operators?
Yes.
Yes. But
Post
12.2.
I understand, but do you know what's happened? Let's see. Gosh. Okay, so are these ones that
So we have marked the ones that are new, and then there are a few on which Mano is still working, and I think we will be able to add them.
What is that one? Two operator logic axioms. What was that one?
It's from NKS. It's just a single axiom that uses only either and or and not.
Did I say where I got it from?
No, but I found a reference from a little bit before NKS was published.
Okay.
So we wanted to confirm names with you.
Hold on, let me look at that one. Is that, I have to find out whether that was the, you remember what page that's on?
I'm checking.
Okay.
There, I've pasted it in chat. It's one of the notes. The last one.
Okay. Yeah, that was not mine. Do you have the actual reference? Did you
Yeah, it looks like it's Mikun et al. Bunch of Argonne guys.
Okay. Well, I think we should call it or not, because it's a minimal axiom. I mean, I'm not sure if it is minimal. I mean, that's just where we get into trouble with it, with our naming scheme.
You mean because you wanted also a person name?
Well, not necessarily, but I mean, it just, I mean, because we're not saying some of these things are Boolean algebra, right?
Well, in principle, we have separated the logic related from the more mathematics related further down.
No, I know, but when we say, you know, Tarski algorithm axioms, then Tarski also had axioms for Hilbert's, you know, for geometry, right?
Right, that's the excluded node further down, which doesn't fall into any of these two categories. So we were not sure where to put it. It's fundamentally different from the rest.
Well, and also, I mean, one issue is, I think this naming scheme that we have is,
We could have a structure of alternate standard names, like it's done multiple times in other places.
I see.
In case you are thinking of alternatives.
Right, where it's like person, what it's an axiom for axioms. I mean, the word axioms is a little bit redundant here, although that will allow us to, by the way, Jose, apparently you are too quiet on the live stream. Is that your wonderful new microphone that I insisted you get, and now it's too quiet?
Not yet, no, this is my old one.
Well, then you're too quiet.
Right, so, okay, so I'll try to adapt the volume.
Try to, what, increase or decrease? Increase.
Increase, yes.
Okay. All right, so I do think we're going to end up going to, okay, first point is, are we going to put these axioms in a repository? What did we decide about that?
I don't think so. I think the idea was to have special documentation pages for them, but still keep them here.
Okay. Why, again, don't we want them in a repository?
I don't know. To me, they are kind of small to deserve to be in our repo.
Well, but they're not going to be small when we start adding to this just a gazillion, things from all these formalized mathematics systems. I mean, look, what we can't put in here is, a random, I don't know, Spinoza's ethics axioms or something. Right? We're not going to, by the time we're doing that, we're going to have, the dining philosophers axioms and things like this, which is going to get crazy.
I see.
Mano, what did we discuss previously about this? Do you recall?
I don't think we've directly discussed putting them in a repository.
Okay. So the reason we didn't do that previously was that we were concerned that this scheme is renaming the operators, right? But I don't think that that's inconsistent with it being in a repository, because as soon as we list the operators, we can trivially do this when we sort of pull them out of the repository. Now, the advantage of putting them in a repository, I mean, the advantage is it becomes a lot easier to add them. And I'm concerned. You understand, when we're looking at adding all these things from these formalized mathematics systems, how are we going to bring them in? Because we're going to have, in a sense, okay, we have two kinds of things. We have what we might think of as base axioms, and then what we might think of as kind of setup for some particular type of thing. That makes sense. Well, for example, for a particular group, do we have do we have things set up in axiomatic theory now to be able to deal with the relations of a particular group?
Yes.
Yes.
Is that documented here?
Yes, I think so. And there are examples.
No. Bzz, bzz. Doesn't
Let's
count
see
as
the last
documentation.
note. The last note.
Okay, all right.
And there are a couple of examples on how to use this in find the equational proof.
Are there examples here of so find equational proof has probably examples of like syllogisms and things.
Right. Yes. So that example you are looking at in the middle, no, a bit up. the first one in your page right now. That one is with the quaternions, the quaternion group.
Well, that's nice. What would be the default if I didn't give multiplication arrow, P, inverse arrow, whatever? What would it look like?
The standard, I think circle times. Try to move it, yeah.
What the heck is that?
Goodness, that must be the new addition of the dataset property. We fixed well, we fixed that yesterday. So perhaps which version is this?
It's really ancient.
A few days ago, yeah. So well, we have fixed that, but
okay. All right. Anyway. All right. But so that is that would be the okay. All right. Look, the general comment, and then we need to move on from this for 12.2. But you know, this whole theorem proving subsystem is becoming a more significant thing, as we can tell by, you know, all these functions are becoming more complicated. I feel like how to think about this, right? Because I mean, you know, by the time we've got specific groups here, we've also got, what about specific, I mean, Mano, you did this translation of the, you know, the Tarski based, you know, that proving some of Euclid's Euclid's theorems from the Tarski axiom system, right? And that has several pieces to it. So in addition to the base Tarski stuff, you also have to define, you know, and I have a circle in this position, which is basically like, you know, what on earth is that like here? Is that like, see, that's not a theorem that follows from the axioms. That's a new piece of information that you're adding. Am I making sense? So it's like a new axiom.
Like a postulate.
Yes. Yes. Well, it's a you know, look, what do we mean by axioms? What do we mean by postulates? I mean, we're saying there exist two circles on the page. That's just like saying there exists an operator with these properties. And so I'm trying to understand, as we have this axiomatic theory thing, we're going to have to, you know, what we're going to need is some kind of compiler from, for example, the geometric. I get very confused here.
So the synthetic geometry group is working on something they call find geometric statements. Or geometric.
Well, no, they've got, yes, that's a thing which, given a setup, will find true facts in that setup.
Exactly, yes. And the idea is to make it work via this framework too. So it will return a proof object, etc.
Yes. You know, okay, we probably yeah, we probably need I mean, we're going to need another discussion about formalized mathematics. I mean, I think okay, let's look at the specific things you want to do here. So I think we already agreed on all of these things here.
Exactly.
And why those futurized? Are they not really futurized?
Well, the ones that are in red have been added already to the system. Okay. The other ones, Manu is still working on them, and they will be added in the next few days. So the main thing here is to make sure that you agree with the names of the properties and names of the theories and the explanations.
Logic type, what's that going to return?
So there's either equational, general predicate, or axiom schema. It depends on how the axiom system works with find equational proof.
I see. Okay. And how do you feed in the logic type to find equational proof?
I'm using entity classes right now, and I'm going to find a way to calculate a property from that.
No, so hold on a second. But
Yeah,
go
I
ahead.
think Stephen didn't mean that. So the idea is that the logic is kind of obvious in what you write in the axioms. Now, this logic is not the logic we will use to prove it. So that's why we distinguish the input logic of the theorems from the logic that is used to prove them, which is always equational.
You can test whether the main predicate is equal. That's pretty straightforward.
What about if there's some that are equal and some that are not?
Then it treats the whole thing as predicate.
But then it needs axioms for the equals, then, doesn't it? Which it wouldn't otherwise need.
Right. But the point being, you can always prove equational theorems from predicate logic, but you can't always prove predicate theorems from equational logic, or from equational axioms, I should say.
Right, but does it automatically add in the equational? I mean, for example, here, we probably need something that says equational axioms.
Yes,
that are the axioms.
But until we have a formal equals predicate, there isn't really a way to do that. I mean, like, it works algorithmically, it doesn't work from a typesetting standpoint.
Because the equals sign, right, evaluates in ways that are unpleasant.
Exactly.
And did we agree on the last time when we were talking about glyph hunting, did we agree what we were going to do for the equals sign in terms of its alternate glyph?
I don't think so. But for example, Mano, what is the symbol you are using for field axioms? You're using some...
I was trying to use dot equals, but I'm running into some problems with that. It's not working with find equational proof as I expected.
Well, does dot equal have some built-in properties?
Not to my knowledge.
So it isn't associative, for example.
I don't think so.
Yeah, right.
Okay, listen, we don't want to take up this meeting for this too much, but let's... All right, so logic type is just a string in this case, is that right?
Yeah.
Probably should be an entity at some point in the future.
Okay.
By the way, are we really calling it axiom schema?
I think it's just going to be higher order logic or something like that.
Yeah, right. Yeah, that should be the name.
Should it be higher order or should it be second order? Or what does it? I don't know what's the right thing there.
Well, from a theorem proving standpoint, it doesn't matter because once the higher order logic theorem proving stuff is in system, it will be able to deal with anything using the same algorithmic techniques. So find equational proof won't care whether it's second order or third order. It's just a question of whether we want to distinguish.
Yes.
But yeah, until we have that meeting about Forall, I can't proceed with that. So
wait. What was the point with Forall?
We need to stop Forall stripping out predicates, which I thought we were going to discuss in this meeting, but it seems.
Well, why aren't we discussing it? Why don't we just do it? Is there any reason not to do it? I think Adam is the keeper of Forall. Could somebody see if they can find Adam? We can have that discussion here.
Yeah, I can try to grab him.
So you're saying the problem is that for all f of x, what do you say? For all f of x fails in some way.
Yeah.
For God's freaking sake, why does it do that?
Well, it kind of makes sense. I mean, Forall, I guess, was designed to quantify over variables.
Well, don't know why it makes sense, because, I mean, what would this otherwise mean?
You're quantifying over a variable that doesn't get used. So it's equivalent to just the...
I see. So the question of usage is really just a question of heads goes to all in the usage checker. And then it will block this one, right? It's probably just doing a free queue of some kind. There's nothing in the documentation that says it shouldn't work. I think it's just a bug. Let's get it fixed. Okay, so let's just go through this. As I say, logic type eventually should be an entity, in my opinion. Okay, ancillary definitions. What are those? Those are operators that are useful ancillary operators. Like, for example, in the case of that's defining something like, and how did we agree that that's defining things like when you have the minimal group, well, we have NAND, for example, it's defining and or not in terms of NAND, right?
Yeah, so I've just made sure that all of the Boolean logic systems have and or not NAND defined.
Okay, okay. Why don't you, I mean, while you're at it, why don't you do XOR and NOR as well? I mean, the named, and I mean, you know, they're easy to get, right? Why don't we put them in? They seem useful.
Yeah, I was planning on it, but I think we're going to need new glyphs for those. The ones that are currently there, I think they have built-in meanings.
I see.
I
see. Okay. So this is a glyph hunt again. Okay.
Mm-hmm.
All right. Okay. I think we should call this or not Boolean axioms.
Okay.
Now, are you going to give the operators, the list of operators for some of these other ones or not? Perhaps not, it's too complicated. I think those are what will go on the subsidiary documentation page. So those ones like equivalential calculus, those come from NKS, is that right? Or are they, where are they, what are those? No, I think maybe, yeah, okay. Are they non-minimal or are they for humans or are they minimal ones?
I think they're for humans. They have easily nameable axioms for the most part.
Okay, fine. All right. What on earth is the meadow theory? What is meadow theory?
Oh, it's just something cool I found. It's basically an alternative to fields, but it's completely equational.
Okay. Well, its documentation page. What a stupid name, meadow. Anyway, never mind. It's funny. Pasture theory. It's like a physicist who's a friend of mine named Rick Field, whose sister actually is a well-known actress named Sally Field, and Sally Field was quoted at some point as saying that she perfectly well knew that this wasn't the correct thing, but that she gathered that her brother had invented this thing called field theory. Okay, that's supposed to be funny. Never mind. I'm sure we can find that quote somewhere on the web. A different field theory, the quantum field theory kind. Okay, never mind. Okay, can we not put in this tasky stuff?
I'm having some problems with the operators. I need to talk to Jonathan about this.
What's wrong with them? Because we don't have glyphs or for some other reason?
I just don't know why dot equal isn't working in find equational proof. I think the way I've written the axioms is correct, but you know, they need to.
So the problem is that when we've used this before, we've just used symbols that are arbitrary system symbols, right? Which we don't want to use here. That's the whole point.
Yeah.
We want to use some kind of operator form. Okay. All right. Well, it's a pity we can't get that in for now, but we're not going to get it in right now. So, okay. Did we manage to find Adam for the Forall discussion?
I couldn't get a hold of him. Tried calling him, and I sent him a couple of notes. But
okay, but so let's just ask him to see if he can't like fix that bug. I think it's just a bug. Let's see if he can fix it. Can you push that, please, Devin?
Yeah, I got it.
And if there's a problem with that, he should send mail about it.
Makes sense. Yep.
Okay. Anything else for this here? Why is this in red?
I think it's just to mark that it's special syntax. With
Okay,
these
fine.
arrows.
Fine.
Hello?
Oh, you just joined us. Okay. Adam, can you explain why this doesn't work and can we make it work?
Let me see. Okay. For all fx, what?
Yeah,
what
we just want it to not evaluate.
Oh. Right. So it interprets f as a variable, so it doesn't look at variables in heads of things.
Right. So you just have to fix that. That's all we're asking.
Okay.
Okay. For
Okay.
12.2.
Okay.
And we might want to add one line to the documentation about that. Okay, that was very easy, guys. Look at how easy that was, Jonathan.
Yeah. Just didn't think about. Yeah.
No, we did. We had
Function name being the quantification over function names. Can you do something with it?
Yes, that's the whole point. Jonathan, you want to say something about that?
Yeah, basically we're using it to represent higher order logics. So where you would conventionally have an axiom schema, we want to be able to quantify over predicates to represent those axiom schemas as second order propositions. But that requires being able to quantify over predicates, which right now we can't do.
Right. Okay. I'll try. So are there algorithms for dealing with it, or it's just for representing things?
There is an algorithm for dealing with it. It works. It's not great, but it works.
So for simple cases, maybe do you have that in the function repository yet, Jonathan?
I do not know.
But it's in the Dropbox heading for the function repository.
It'll be in the physics Dropbox somewhere. Yeah.
Let's just show Adam for a second. Just to is it in not ready?
I forget where it is.
It's in JG drafts. Find higher order logic proof.
That's the one.
All right. So this claims to be, if we run find higher order logic proof. So what did you have here? This is one where you can't do it because of the
Well, so I'm, as you can see, I'm using hold form to stop Forall from evaluating.
Oh, okay. So that's for all f.
Right, exactly. So it's saying basically here we're just going to say every binary predicate you see is commutative. So f of x y equals f of y x for all f, and then using that commutativity, we're going to prove something.
Oh, nice. Okay, I'll fix it then.
Yeah, here's a more interesting example, which is an induction schema. So for all predicates phi, if phi of x is true, then phi of successor of x is true.
Oh, right.
Why is this coming out as proof objects which look like garbage?
Because proof object higher order logic isn't that we don't have a make boxes rule for that. I'm going to add one, but
okay. But so if I say this here is proof graph, it'll probably do the right thing.
I think so.
No, it doesn't. Oh well. Okay.
Yeah, the logic needs to be registered.
Right.
What do you mean the logic needs to be registered?
That the system has a logic queue somewhere, and if it doesn't recognize yet that logic, then some things will not work, like the summary box.
I see. Okay. All right. Well, okay. We're going to be having a subsequent discussion about more of this formalized mathematics stuff. But okay, Adam will fix that. Terrific. Let's just see whether we need to make a change to the Forall documentation page to refer to that. Okay, so you may need to make some small change here, Adam. Propose.
Okay, I'll check it. Whether
okay.
It's Okay.
Terrific. Okay, thanks, Adam. Yeah.
Sure.
Bye.
Bye.
Okay, let's go on. I think that was everything for axiomatic theory. Is that correct, guys?
Yep, I think so.
Okay, great. So Mano and Jonathan can depart if they wish to do so, and we will go on with our next items.
Thanks.
Right,
Thanks.
so now we have the 4 echo functions, which we have looked at several times, but the pages are still featurized.
Okay. I thought I mean, how are we finished with these? Is there anything about these designs that we're not happy with?
No, I think it's all fine. We have tried to knit them a bit, but I think we
Okay.
didn't
So
add them.
you want me to hit the defuturize button, basically.
Yes, it's some final yes, approval and say.
Okay. Are we
defuturize.
thinking they're experimental? I don't think they're particularly experimental. I'm not worried about them.
No, I don't think so. What do you think, Ian?
Echo timing, I think, is supposed to remain experimental because of the method option.
Okay.
That relative for CPU versus absolute timing?
Right.
Okay.
Okay, and then we got to do some knitting. Gosh, QuietEcho is probably got yet another piece of semantic horror with what is QuietEcho again?
It's a way to disable of the echo family.
Oh, I see. That's harmless enough.
Yeah, it's useful when, yeah, because now we all use echo multiple times, so it's good to be able to disable them all.
Okay.
Shouldn't that have something like, abort protect as a related?
Why?
Or well, similar idea of stopping a function from acting.
I don't think so. I think
All
that
right.
will be confusing to people.
Okay.
All right. Let's look at the guide pages for these. Where have you put them in terms of guide pages? Well, let's look at where I have to go. Oh my gosh, my elephant has been retired. For searching these things.
Shouldn't echo timing refer to timing as related?
Sure should, yes. Wait a minute, does that have a C also? Yes, it does refer to timing. Now, timing should probably refer to timing and absolute timing and so on. They need to refer to echo timing.
Right. I think we didn't do the back knitting.
Yes.
Okay.
I don't know how I missed the timing in the echo timing. See also.
I think it's C also blindness.
Could be.
Okay. Now these ones. Did you do the seal sewing between echo and echo label and all that kind of stuff?
Yes, those are them.
Okay. But the out of echo stuff isn't.
Exactly.
Does quiet.
Or the guide pages.
I added some tentative knitting to guide pages that are in chat.
Okay, all right. Let me look at those in a second. Yeah, QuietEcho needs to go at the end here because it's really a different thing. Let's also have. Does print probably points to echo, right? But it doesn't point to any of the other things. By the way, we don't have any kind of echo temporary, do we?
Temporary, no. That's an interesting idea.
Right. Okay. Let's look at guide page stuff here. Debugging. Okay, so we've got time measurement and optimization. We've got tuning and debugging. And we've got basic input and output and programs. Boy, why are these made so small? Why are they? Okay. Echo function. That seems okay. Oh, for goodness sake. Why is this tagged for 12.1? Could you let the documentation people? I don't know that I can fix that. Why is this defaulting? This is crazy. Why is this defaulting to 12.1?
I don't know.
And why is it saying 12.1 plus anyway? It should be a 12.1 whatever. And by the way, that is clearly wrong. That should be, Devin, can you point that out to documentation people? That should be a italic string. I don't know how to do that here.
Yep, yeah, I got it.
Well, this is a weird page anyway. I guess it's okay to list all of these here. What does echo evaluate? Oh yeah, I know what that does. You know what echo evaluation should point to? It should point to in out. And it should point to probably it should point to dialogue. Because it's simulating in-out behavior, right?
Right. The idea of in-out is very good, yes. Not so sure about dialogue because there is no interactivity here.
Wait a minute, are you editing this page? Wait a minute, what's happening here? Oh gosh, don't tell me this is being pulled up in both versions here. Oh no! Okay, bit of a disaster there.
Why? What happened?
I had two different versions open and they stepped on each other.
Oh, I see.
That should be okay.
Well, with the recording, we can reconstruct in case it's needed.
Yeah, hopefully it won't be needed. Okay. I want to come back to this page. You know what? I don't like this. Let's actually write why we're doing this here. Oops. Print an expression. How are we going to say this? And return the expression.
Well, we could just say that print and return an expression.
Okay, now how do we describe some of these other things? Which other ones do we think are important here?
In my opinion, the second one is echo timing, and probably the third, echo evaluation, with function and label being just operator forms of echo.
Yeah, I don't think those are so important for this page. Those are more sophisticated things.
Right. So echo timing is, right now I see myself using echo timing a lot.
But maybe that's not for this page.
Oh, I see. Yeah, it will be better in the tuning.
Right. Echo evaluation is more for this page, I think.
Right.
That's about it for this page, in my opinion.
Okay.
Okay, now let's go to the next page. Now, this robustness and error handling page, which is new, is all about confirm and so on. And this says code monitoring, print an intermediate result. So I think there we should add at least a, let's just add echo timing and echo evaluation and echo timing. And maybe echo function here. Maybe these echo label. All of that's the whole family, right?
Yes, there's QuietEcho.
I know we don't need to add that here. This is not relevant to this page. Okay. Now, tuning and debugging. Does that now point to the okay, hold on. All right. Oh, for God's sake, you got to tell these guys it's wrong. So I'm sorry if somebody sets this correctly, I will get it right. Otherwise, I'm not going to get it right.
Yeah, we will fix that.
All right. I'm not sure this is right to list all of these. And look at the rest of this page. Okay, there's no way this page is the key page for this. What was the other one? Actually, this really isn't right. Well, maybe it is.
I think that the debugging, the scenario of debugging is the one in which all the echo functions are used most.
Okay. Okay. All right, that looks okay. Okay. Anything else here?
No, I don't think so.
Okay.
So the next two are the
Oops,
functions.
wait. What
Sorry.
happened here? Oh, that's that one. Okay. Let me just check echo evaluation to check we didn't mess something up there. No, it looks fine. Okay. Right, next. FoldWhile list.
Yes. So these are another two pages that we looked at already at.
And are there potential issues with this? Did we solve the problem of what does it do in certain corner cases?
Right. So there are the final arguments, and here we follow next while, same type of structure. So I think it's fine.
You think we're done here, right?
Yeah, I think so.
Okay. Did we knit it?
Probably not. There are two guide pages called functional programming and functional iteration, which look.
Why aren't we pointing this to things like take while? Isn't take while relevant to this?
It's not exact. Yeah, it's similar. Yes, we could certainly.
What the heck is sequence fold? Why do I not even remember it exists?
Yeah, so this is the fold variant of the sequence family.
My God. You see, this is upsetting because, it's like this is what happens if you introduce these functions 30 years later is you just don't remember they exist.
But this is particularly, this is not that old.
I know it's not that old.
Yeah, so this, yeah.
Right. This is the multi-argument folding story.
Right.
In which you have a prefix that can be any number of things here.
Mm-hmm. Right.
I see. And then you're starting to fold in the things. After the prefix, you start to fold things in.
Right. So in FoldWhile, there is also an argument of number of variables that you feed to the test function. So it's separate, it's different. So it's not to the function being applied, but to the test.
I understand. Function. By the way, Atom on our live stream is asking, why does QuietEcho behave globally? Why not have echo disable, echo enable? Because QuietEcho is a wrapper. Right, it's for functional programming. So you wrap it around things and everything that is in its sub, if you want to, there's no way to unquiet, given that you put the wrapper QuietEcho around something, there's no way to have, in other words, if I say echo, let's say I say echo evaluation 2 + 4. Okay, now I say QuietEcho that. I'll just get that. But there's no way that I can, I could put echo evaluation in here.
Right.
Is that what I expect? Okay, hold on. Let me try to understand this. Oh my God, this is so difficult to understand. Is there any possibility of a jump down link here?
What do you mean?
That I click on that and it goes down here?
Oh. Perhaps we would have to do some dynamic something there.
I'm not sure it would have to be dynamic. Let's ask the front end team whether there's any possibility of that, or any possibility of having it light up or something.
Okay.
Because that would seem quite useful to me. I mean, the fact that I had to think
you
about
can
this.
mouse over the after prints, so the 13 or the 11.
And it shows me what the input was.
Yep.
That's useful. Does it say that in the documentation anywhere?
No, I can add that.
That's nice. I didn't know that.
Right. What is the is that input form that it's showing in the tooltip? We probably want to make sure it's standard form in the tooltip.
Should be standard form.
Okay. Oh yeah, looks fine. Okay, I'm gonna have to go soon. Let me just see how we're doing on the meeting. Agenda. Okay, FoldWhile list. Did we knit those? Do we know how they're knitting?
There are two natural guide pages. One is called functional programming. The other is functional iteration.
That's a bit disappointing that we have summary. Oh, in 12.2. Wait a minute. FoldWhile. Oh yeah, that's because it's new.
Right.
Okay, functional iteration. It would go under, presumably under here, right?
I think so.
And okay, what's the right way to describe this? Fold while a criterion is true. Well, a condition is satisfied, actually, is to be. Do you think that's the right place for it, or should it go above the sequence folds and so on?
I don't know. They are all equivalently important. Perhaps we put it before because it's newer, so it gets a bit more publicity.
No, that's that. No, in another 3 years, it won't be newer.
Right. Okay.
No, I think it's fine. Yep. Okay.
I'm not sure whether it's a condition. It's more like a test. So it's not an expression that has to be true. It's a function that gets applied.
Isn't that how take while and length while work as well?
Yes, I think so. Okay. Okay, fine. Just to be consistent with the warning.
Right. I kind of think we should just replace one of these. We just say sequence fold list, fold pair, and then fold while. What do you think? And then you go to the subpage to see the list versions.
Okay.
Okay. Now, can somebody else knit these? Could you knit them onto the back knitting places where they need to do back knitting? Okay, so that we just have a chance to look at that last agenda item.
Right.
Oh boy, is this horrifying?
Well, we started a discussion of how to represent leap days, and we have asked some people from India and China how do they do things, and
Okay.
so these are the options that we see as most reasonable.
Okay. So I mean, clearly the word leap isn't going to make it as a wrapper like that. I mean, if we're going to do that, it should be something like leap date or something, or leap. Do they call them leaps?
Each language will use a different name, but I think the general concept is being leap day, leap month, leap week. The problem is that it's a granularity. The thing is a leap granularity, but it sounds very technical. So what about the idea of having a string instead of a single?
Well, not like that, no. I think we should have a, okay, hold on. Okay, let's look at the cases where this occurs. So if I say,
so this
I don't
is an
understand.
example. Yes, so this is an example in which both there are both leap months, that's the second column, and leap days, that's the third column.
Okay, leap day, I understand. Wait a minute. What is a leap? Is February 29th a leap day?
Yes, that's a leap day.
But would I wrap it in leap? Or what would I say for, would I say leap of 28th to represent the 29th, or what would I do?
I mean, we could have used that convention. It's just that we invented the new convention of having a different number because it happens once every 4 years, so it's not very frequent. But here in these calendars, any day can be leap.
But a leap means an extension of the a new copy of the day.
Exactly, repeated. It's two consecutive names with the same, 2 consecutive days with the same name.
And why not? Why can't it be 3 consecutive days or 5 consecutive days?
Because this happens in things that get slightly synchronized, desynchronized, like a lunar day is slightly smaller than a solar day, and that happens every few weeks. It will happen that you have to
right, but you'll never get it far off enough. I mean, back in antiquity, people had half years that they added and subtracted, right?
Yes, but they wouldn't call it leap. They may have some.
It's a generalized leap. Okay, so what this is a
yeah, it's like when you have in the streets, they introduce a new door and they put the same number as the previous one with a B. So we are looking for the equivalent of that B here.
Right.
So the main question is whether we denote all days with true or false, which is what is being done here.
No way.
Or we just reserve something for the leap ones.
Yeah, reserve something for the leap ones.
Right.
Like leap variant.
Mm-hmm.
But does it always follow? Is it always the leap variant is always the following of the, I mean, leap variant of 3 means the redoubling of 3, is that correct?
Yes, but it's true that in some cases they may decide that the first one is the leap one and not the second one.
So maybe what we should do is leap variant 3,2 means that everything could have a leap variant, but the default leap variant, or 3,1, the default leap variant, the leap variant is the offset.
I see.
So that's the offset. It's the base number, and then it's an offset. And so leap variant, 0 would default back to just 3.
Okay. And so if we could use leap, so 3 leap variant of 3, that's the first leap. And if needed to have more, we would just add 2, 3.
Exactly. Leap variant of 3 would be leap variant of 3,1.
Right.
Leap variant of 3,0 would be just 3. And leap variant of 3, -1 would be some kind of bizarre version of where the hiccup is added before the thing.
I see what you mean. Because that gives information of where is the true one, before or after.
Exactly.
That might be useful, yeah. I like that.
Brian is asking, are there leap seconds, leap minutes? Yes, there are. I mean, there aren't leap minutes in the modern world.
Right. Yes, leap seconds, the standard thing is, rather than 59 to be the last one, they call it 60, the last one. So that minute goes to from 0 to 60,999.
Yeah, which we could handle with this leap variant idea. I like leap variant. I mean, it's a pretty obscure concept, but it's still, I mean, and that means that leap variant of February 28th should just work. You know, leap variant of 28th should work for the regular calendar. Okay. Nick, any comments on this?
No, I think it's a pretty good solution here that lets us adapt it for, you know, there aren't very many calendars that have complications where we'd need a multiple offset, but it's good to future-proof against that. And like you said, you could have leap variant just normalize out. You know, if you said leap variant of the 3rd during a Gregorian day, we'd know it's just, oh, you mean the 4th day. But
right,
we already have a normalization routine for those things. So I think it's fairly descriptive, and it gives us a ref page to talk specifically about these complicated cases. So works for me.
Good. I mean, I think, look, by the way, you say future proofing, it's really past proofing.
Yeah. Complexity proofing, I guess.
Right. Let's see if we can get the Babylonians covered by this.
Yeah, we had a bit of a discussion with Christopher about that, and it's definitely complicated. And I've been working on the Japanese calendar, which has some similar complications with adopting and then dropping and then adding back in and blank periods and far future, far past. So we're definitely covering a lot of complicated cases already, which gives us hope for dealing with really nuanced calendars in the future.
Right. Sounds good. All right, we should wrap up here. By the way, for people on the live stream who are interested, we will be talking about machine learning at the top of the next hour. And off I go to something completely different. All right, thanks, guys. I just pushed the documentation updates. They should be showing up.
Perfect.